Hi everyone. Today we are going to solve the height of the tree using breadth first search, which is also called as level order traversal. So the idea is to find the height of the tree, right? So we need to go level by level. So this one gives me the height of one, and this two, three will give me the height of two, and the next children's of two and three will give me the height of three. So how to solve this one? Here we are getting the each level, right? So we have one gives me the height one, right? And next the children's of one will give me the height of two, and next the children's of the children's of the children's of them will give the height of three, and so on, right? So we need to we need to use some data structure. Let's say I use uh, some data structure. We don't know what is a data structure. What it should do is, first it should hold the one, which gives me the height one, and next it should remove one and it should add two and three, which are the childrens of one, which will give the height two, and next it will remove both of them, and next we need to add the childrens of 2 and 3, right? which is 7 which is 7, 5 and 4, right? So 7, 5 and 4, so this gives me the height of 3, and next we don't have any more childrens for 7, 5 and 4, so we remove them, and the data structure will become empty, and we stop as soon as our data structure becomes empty. Okay, so let's write the algorithm. I'll give you the code in the description. I'll just write the algorithm here. So let me first erase whatever I've written, right? So in this data structure, first I'm going to add the, so this data structure, what are the values this data structure is holding? This data structure is holding the tree node. This is not the integer. This is holding the entire tree node. Okay. So first we need to add the root, right, to this data structure. So this data structure dot add the we add the root to this data structure, and then we just uh, while it is not empty, data structure is not empty, we need to continue this while loop, right? Let me write like this to understand. Okay, and what we should do now, we should we have the height, right? We also take the height, which is 0 currently, and this we added 1 to this data structure, and this one gives me the height 1, right? So we'll increment the height becomes now 1. Okay, now the height has become 1, and we get the size of the data structure. We get the size of the data structure, which is 1 currently. We get the size of the data structure in the variable size, and we loop through this size. We add the children in this size. We add the children for the current node, right? And before, the size is 1 currently, because the data structure has tree node 1, and we remove the 1. We remove 1 and we add the childrens of 1. What are the childrens of 1? So the 2 and 3 are the childrens of 1, right? So we first check where we need to get this tree node into some node, right? So we take something called current node. We took current node 1 inside them, so we just write current node equal to data structure dot remove. We removed, all right, and then we add if If left child there, add it to the data structure. So we added 2, which is a left child for 1, and if right child is there, we add that to the data structure, and we have 3, both got added, and this for loop is completed, right? So it will run only one time because the size is 1. And next it again goes to this while loop, and it will check if the data structure is empty. It's not empty, so it will increment the height to 2, right? And then we have to add the childrens of 2 and 3, right? We remove 2. We come to this for loop, which will run now 2 times. The size become 2, so the current size is 2. We remove 2. We add the childrens of 2, which is 7, and we remove 3. We add 5, 4, right? That's what this for loop is doing. This for loop is removing from the front. So this for loop is removing from the front and adding the children for the next level to get the height. And now the while loop will get the height 3, right? So now the height has become 3. Now there are no children for 7, 5 and 4, so we remove them in this for loop. So in this so these got removed by this for loop, right? So now the data structure has become empty, so we return the whatever height we got. Okay, so this is our entire algorithm. So I'll explain it again. First we add the root to our data structure, and the current data structure is not empty, so we increase the height for the current root, and then we get the size. We loop through the size and we add the children's for the current parent. Okay, so what is the best data structure that I can use for this problem? What is the best? Let me write down here. What is the best data structure that I can use? Let's say we are using a stack. Okay, so I have a 1, 2, 3, 4, null, null, and 5. Let's say this is the tree. Let's say this is my stack. Okay, every time what I'm doing, this is my height 0, and this is the current node, right? Current node. What I'm doing, first I'll add root, right, to the stack. I'll add 1, and I'll increase the height, and it enters the for loop, right? It enters this for loop, this for loop. What it will do, so the current size is 1 because the stack has only one value. So we just pop and put it in the current node, and we add the childrens of 1, right? What are the childrens of 1? Those were 2 and 3. So we add 2 and 3 to our stack, and then I'll increase the height, and then we again pop 3. So the current node has become 3, and now the size is 2, right? The size is 2. So the for loop will run 2 times. So the for loop has to add the childrens of both 2 and 3. But here, if we pop the 3, we are popping 3 and we are adding the childrens of 3, right? So the childrens of 3 were 5, right? And next it will run again. The for loop will run again, and this time it, instead of popping 2, so we need to pop 2, and we have to add the childs of 2, but that is not happening with the stack. It is popping 5 instead. It is popping 5, and it is adding its childs. So there are no childs for 5. It is not adding anything. So now the height has become 3, and now the size is becoming 1 because we have only one value, which is 2, in the stack. So the two childs were 4, right? So it will add 4. It will run only one time. It will add 4. The current node will becoming 2. We popped 2 and we added 4, and then the height has becoming 4, right? And we pop 4 and we add childrens of 4. There are no childrens of 4, so the stack is becoming empty. So instead of getting, so if we use stack, we get height has 4 for this tree, but the height is 3. But the Yeah, but the actual height is 3. That's why we cannot use stack. So what is the other data structure that I can use? Let's say I use a array list here. For the same problem, if I use the array list, so this is array list, I have to add 1, and then I'll remove 1, and I'll make the height to 1. I have to add 2, 3. I need to remove 2 and add its childs, and I have to remove 3 and add its childs, right? So removing from the front, we have to always remove from the front, which this cost order of n in array list, and adding at the end, which is also order of n sometimes, if my if there are if there are more nodes at some level in tree. So I cannot use an array list. So what is the next thing I can try? I can use a queue, because in queue I can add 1 from the end, and I can remove it from the front in order of 1, and in order of 1 I can add 2 and 3. I can remove 2, I can add its children. I can remove 3, I can add its children, right? So the data structure that we have to use is queue, and I can provide you the solution in the description below. Thank you.